Hello everyone, once again. In today's lecture, we're talking about one of the medium resistance measurement tool, that is Wheatstone. It is a very reliable and one of the famous bridge of measurement used in our laboratory segments. In this particular segment, it is basically developed by the Charles Wheatstone. It is a basically diamond shape circuit, basically depending upon the we're talking about one of the type of measurement tool, that is called non-deflection method. Okay, in this method we will propose that if the one of the branch carrying current is zero, then all our bridge should be balanced such that both the circuit are having the equal currents, or the particular ratio of their resistance should be in a ratio such that we can note it the basically the unknown resistance in the circuit. The bridge balancing, nothing, we can also say it is a two simple series parallel arrangement of resistance connected between the voltage supply terminals and grounded, producing the some zero voltage between the two parallel branch when balanced. So what should be the its construction is a basic construction you see in your right hand side, where we apply some voltage source Vs. Okay, there's a voltage source Vs. This voltage source Vs is applied across some branches R1, R2, R3, R4, where we have a three resistance should be known. R1 should be known, R3 should be known. When one of the resistance branch should be variable enough, and we have to find out some of the resistance that in particular case we wanted to be R2 to be as an unknown resistance, and we will have some galvanometer that is acted as a galvanometer, or any ammeter is in the particular manner. It will note it down the current in this particular middle branch. So what should it matter? The basic method of a principal construction, that we will vary this particular resistance R such that this galvanometer show the null deflection of current should be equal. What will happen by this will case that this particular resistance R3, R4, or say voltage drop across AB should be equal to voltage drop across this particular branch AB. If the both the branches have an equal voltage drop, or we say in this particular manner, we will consider that if the voltage of EC, if voltage at EC is equal to voltage equal to ED, then if voltage are equal, then there is no current that should be flowing through this particular circuit. There are basic fundamental behind it. For the EC is equal to ED, we have to be noted that the voltage across this particular R1 must be equal to voltage drop across this R3 terminal. And also in same manner we can say ECB voltage should be equal to the EBD voltage. Okay, if both the voltage, if we say ER1 voltage is equal to ER3, then there should be no current flowing this particular branch, and we can say the ratio again we suggested in next particular circuit also. Okay, now what should be the circuit? This circuit suggesting that we have to find out the unknown resistance Rx, where the variable resistance is R3, and we have some voltage V should be there. If voltage Vc minus Vd, okay, if Vc is there and Vd voltage should be there, if the both the voltage are equal, then if Vc is equal to Vt in case of balanced bridge, then Vc minus Vd is equal to 0. Okay, and we can say bridge should be balanced. And how should we go through this? For this we have to vary this particular value of R3. Okay, how should we manage to do this? We should manage to do this by using some bridge balancing condition cases. Okay, how should we do? So we should that when the resistance in R1 and R2, as we see in the particular circuit, are to be known, we say is if they are the fixed values. In case of your balanced bridge condition can be suggested as this particular, what we wanted, that the total resistance across this particular value of RC, then RC resistance should be equal to R2 upon R1 upon R2. Okay, it is basically a voltage drop condition where when we wanted to find out the voltage across RD, it's equal to R4 upon, that is unknown resistance, upon R3 upon R4. When both the resistance at RC and RD are equal, then we can suggested that then R4, our unknown resistance, can be equated by R2 R3 upon R1. That is our one of the bridge balancing condition for Wheatstone bridge. What are the limitation of this bridge balancing condition? The one of the major limitation of Wheatstone bridge, that it cannot measure the resistance of low resistance as we suggested, the lead contacts, causing one of the introducing error. And cannot measure the high resistance, like as galvanometer is insensitive to imbalancing condition. And one of the important thing, this the resistance due to the circuit heating effect causing the excessive current to be there. And if we use the measure the higher resistance, I square RT losses are within grid. Okay, as the application perspective, precision measurement for low resistance and can be used for operation amplification purposes for physical parameter like temperature, light and stand, and quantities like impedance, inductance and capacitance can be measured very accurately using this there. Thank you so much for this particular lecture where we're talking about Wheatstone.